Can someone sign into Slack? The link is pinned in the StuySplash.
This one?
Wait, I don't know. These are people.
Okay, you must have just not added audio because for the others it's fine.
Okay, now.
It should have audio now.
Now and now.
Okay.
Let's make sure this
So the
works.
first entire presentation just should no audio. Yeah.
Mr. Blaze not presenting today. Isn't he in the Yeah. Dude, I went to so many efforts to make sure everyone got the schedule. Why did he want so much schedule? That's okay. Ooh, deep breaths. Anyway, I have to move it.
But like, it's not really good. Like, as long as the centers are like,
Is he not?
if it's not, you should make sure they get some.
Usually they enjoy doing art, so that's
I know. I really, I don't know. I wish.
There's like motivated people, so you find those people.
Yeah. That's why you make sure you change your rules. Oh, I can tell them. I'm not talking about a lot of stuff because like,
We use this. At the end, if we want to show code, we'll just plug in our laptop, and then the stream will suffer. That's fine. You don't have to change it. If it's working now, it's working.
He's also webcam.
At our chest.
Wait, where are you gonna stand? Stand where you're gonna stand. Where are you gonna stand when you present?
Why not here?
Do you know how to access the
I'm waiting for so long.
slides? Why do you have two laptops?
Yeah, this one. Okay, we're not using this one. This has this one.
Just remove it, sign out, bring it back to where it's supposed to be.
I'll let them do whatever first.
How do I go? How do I go to the browser?
How do I use the laptop?
Yeah, I don't know, man.
Here? Wait, what?
Because you guys can't access the next slides, right?
Yeah. Wait, where's? Yeah.
You have to go onto Slack, please.
Oh. Can we sign into our account still?
I think everything's on. Oh, everything's on that one document,
That one
right?
document.
Yeah, you can get that document too. Wait, can we use our laptop as like notes?
You can pull up another. Yeah, you can pull up
Yeah.
another one.
I'm gonna try to add it to the drive in a second, but it's on.
What?
It's pinned on Slack. The StuySplash.
Okay. I don't know whose account of Slack I'm signing into right now.
I'm so stupid.
I signed into StuySplash. Pinned. How do I find pinned stuff? Oh, here. Here. Your slide should be on here. Wait, where are you gonna stand?
I mean, then why didn't I get it?
Okay.
Why? Well, no.
Oh,
I don't know. We're taking that
how does this
laptop
thing
out.
say?
We're taking that laptop out. So we can use ours. Yeah.
Colin.
And so no, not in the
Why?
lab.
Somewhere else. Would you like to sign out of this computer, April? I'll just put.
Is there any other interesting things?
Can you shift it over?
Place it wherever you like.
Okay. I don't know where's the water.
Wait, I'll put it on this laptop. Wait, I don't know which.
Well, I'll actually like.
I'll put it on this one.
Where? Okay.
This looks okay, right? Here we can start the OBS, I guess.
And no, did you learn?
There's a lot.
The trick is to keep going.
What is that?
annoy them to get
Did
jobs.
we not go live?
I mean, I guess. Are the two viewers like us?
Yeah.
Okay.
Oh my god. It's okay. Also, there's more viewers than my Twitch channel.
I don't hear anything though.
Bro, me when swiping the card changes.
I don't hear anything. Wow. Here, there's something here. Why mic audio?
I thought this was my turn. I'm bringing my shirt.
Why is the audio not working?
Hold on, man.
Oh wait, it is working.
I should have.
It is working.
When you're in a slide.
Please stand within the range of the camera. So like next to each other.
Why don't you like just turn this?
No, it's I had it set up.
Yeah, so you can look at your notes.
So if someone stand in front of here and someone stand in front of here. Okay. Everything
All we have to do is HDMI plug it in.
Yeah, I'll plug it in now. Yeah, let's plug it in now. We're live. Yeah, we're live.
We've been live.
We've been live.
We've been live. For that.
And now I have the Lawrence.
What time are you guys
Can we
starting?
get more seats for them? Or?
Oh yeah.
This is not stable.
Do you want a chair? You want a chair? It's gonna get stools.
I'd like to.
We can take those two stools.
We should just stand.
Guys, there's a bunch of seats.
My life. I want to rollerblading.
Rollerblading?
Honestly, you probably can't see me. That's fine.
That's a fact.
Well, just over there.
We'll just swap spaces, I guess. We'll just have seats just in case you want to sit. Oh, I should turn off auto sleep. How do I make it not sleep?
Prevent auto.
Raise your hand if you still need a seat.
Focus lock screen settings.
Anyone else still need a seat?
Lock screen settings. Turn display off on battery when inactive.
What? Where?
Turn display off on battery when inactive. Says to never.
Okay. Never sleeping may shorten your battery life.
Yeah.
I guess.
Never sleeping.
I guess.
Shorten your lifespan.
I mean, that might. I don't know. Like I'm there. I'm in a review. Like, do you have a time?
Also got time
It's
to
supposed to be 10:45. We're not gonna take the whole.
Yeah. There's no way. We don't even have that much time.
Yeah. When is the? You can know this stuff. We don't have the schedule.
I speak really loud before I can hear after. It sounds enthusiastic.
Okay.
Some people don't like go on the phones.
1:45. Apparently.
It's okay. I have full set to punch me if I start rambling.
I'll let this be right.
Okay.
1:45, which is good. So you want to start at 10:50? 3 minutes.
If you start rambling, just make it make sense.
You want to start at 10:50?
Make it
When
interesting.
is your slot?
10:45 to 1:45.
Alright,
Oh, I know you like.
I'm gonna go back there and moderate the chat.
Really?
Yes.
How many people are in the chat?
Two. I'm literally the Discord moderator. It's 2 people and one of them is you. I'm literally the Discord mod.
Also, haven't we been live?
Yeah.
Oh, is this stream on stream, dog? Come on now.
Bro, you do not have to do anything like that. Are we biased actually?
Are you time?
Are we biased? You should be doing your job right now.
Is this water? Close the freaking door and then the thing.
Precarious situation.
These things are.
Yeah.
Alright, they ready?
Yeah, you can start. Who's that?
No, that guy.
Oh yeah, what's he do?
I guess it's.
Okay. Alright, can we start? It's hard and stuff. Alright.
Alright.
Hello everyone, welcome.
Alright,
You want me to do it?
yeah.
Alright, hello everyone, welcome. We're gonna get started. So just quiet down. We're gonna be talking about finite state machines today. Okay, so let's get started.
Alright, a little bit about us. As you can see, we're two dashing gentlemen. My name's Lawad, I'm president of Q479. This is.
And I'm Paul, vice president of 310. We're FTC teams here at Stuyvesant. And yeah.
Okay, so what is a finite state machine? Based on the name, as you probably tell, it's anything that can exist in like a single state at any given time. So like a single like mode of being, right? And you can transition between those states in a non-linear manner. So if you have like a bunch of possible like modes of operation, there's no discrete order into like what you're going to be doing at any given time. And they're defined by all the possible states you can be in, the state that you start off on, and what causes a transition between different states. So, example of that is like a turnstile, right? If you go on the subway, to get in, you gotta swipe your card, right? Because otherwise it's locked. If you push on a locked turnstile, it doesn't actually change what's going on, right? It stays locked. But when you swipe your card, it's unlocked. If you keep swiping, well, it's not gonna change anything, right? It's gonna stay unlocked. But when you push it to go through, it'll be locked again. So those are like the two states that a turnstile operates between. And the inputs that cause it to change are swiping your card and pushing the turnstile. Then more complicated example is like a video game character, right? Say you can either be like standing, jumping, or running. Then if you're not doing anything at any given moment, you're gonna just be standing, right? Then say I press A, I'm gonna start jumping. If I keep pressing A, I'm gonna keep jumping. If I press B, I'm gonna start running. And if I keep pressing B, I'm gonna keep running. Doing nothing from any of those states brings me back to standing. And so again, there's no like order to what there's no order to like how I can move, right? I can start by running and then jump later, or I can start by jumping, run later, or whatever, right? There's a nonlinear, it's like a nonlinear flow here. And it's all governed by the inputs that you can do. Just pressing buttons or just doing nothing. And you can probably tell based on like the way robots work, right? Robots are event driven. An event is something that causes a change in state, right? So stuff like sensory feedback, like camera vision detecting an object, or odometry knowing where you are on the position, or even like as we did before, like pressing a button, they're all like they can all cause changes of state. For example, like having a game element, right? It might cause something to happen with your intake. So yeah. And as a result, finite state machines are useful for automating like complex tasks, right? A scoring mechanism is made up of like multiple components, right? Like an arm and a lift. Being able to have all that work in tandem in like nice and clean way is a lot simpler to do with a finite state machine. Similarly, it makes it easy to abstract that code for later use, right? You don't want to have to be dealing with nuance when you're building like overarching robot code. You just want to make sure that things work, and Finite State Machine is good for that. Similarly, implementing like interrupts, delays, which is, I guess, it's part of like making the whole operation clean. It's a lot easier with this kind of layout as opposed to like an if statement or like other systems, which we're gonna go over like right now. Finite state machines are implemented with switch case statements. So a switch operates on an enum is like a numerator value. We'll go over that in a bit. But you can think of it like a switch case is given a value, it'll operate like different branches. So depending on what state I'm in, a different event is going to occur. That's how we're going to be implementing that in the code.
All right, so an enum in Java, it represents a group of constants like unchangeable variables, like final variables. In Java, you declare a variable final, it's unchangeable. And the naming convention for enums, just like final variables, is like block capital letters. And these are often used in switch cases, like we'll show switch statements. And it's a way to organize and navigate through states. So each enum represents a state that your robot can be in. So intaking, lifting, and scoring, and then resetting to bring you back to the start. These enums should be clearly defined and clear to read, because when you go through your code, you can clearly see what the robot might be doing at a given state, whatever it's in. So here's going to be the setup for our example today. We have our enum that I showed before, which is our score state, which is the 4 different states that we defined. And then we declare a variable of type score state that will keep track of the current state that we can always look back on to check what state the robot's in. And we'll initialize it on what we want the robot to start doing. Like we said, it's non-linear, but you need a starting point. And the starting point for us will be intaking to acquire a game piece. And then from there, we'll do, we'll score it, and then we'll do whatever we want with it. And then we have our 3 mechanisms that we're going to be looking at, which is our intake, a sensor to help switch through and our states, and then also our lift, obviously. Okay, so here's an example of this without a finite state machine using if statements. So we look at our gamepad input. Right trigger will be our acquirer, and then if we're not pressing right trigger, the acquirer won't do anything. And then gamepad Y, X, and A are for lifts and scoring. Major drawbacks of this is it requires 4 different gamepad inputs to score a single game element, which is a lot to think about as a driver during a match when you're trying to drive around and navigate and perform strategy. But you also have to press these 4 buttons to score a single piece of single game element. And that's also taxing on the driver because the driver has to visually confirm that these actions have completed before continuing to the next one. So like if the driver didn't properly acquire a game element and presses Y to raise the lift, now you have a raised lift and no game element, so you have to reset and try to do it again. It's a pain because you can easily mess up, and also on top of that, you can accidentally raise the lift when you never wanted to. Like if you press Y or A and you change the lift position, it's kind of useless because you only want to raise the lift whenever you have a game element. Okay, so let's look at the first part, which is just acquiring, and we'll see what that'll look like in an FSM. Okay, so we're in our intaking state, which means that we have to acquire a game element, and then that'll run autonomously throughout the game loop. So this is all contained inside of like a while out mode is active. So like while your robot is initialized and running, this is a loop that'll constantly run. And the intake state is what we define it'll be starting as. So we'll be looking through this case and repeating it as the op mode continues. So we're going to be acquiring constantly. So the driver no longer has to press a button to acquire. It's going to be happening, and the driver can focus on driving right now. And then we'll use a sensor here to check if we've acquired a game element. And then we know then that we don't need to intake anymore because we have a game element. And then we can focus on lifting our lift. Yes. So yeah, the benefits are pretty clear here. There is 0 driver input required. All the driver has to do is drive around and acquire a game element. So yeah, and there is no like way you can mess up. You can't press any buttons here that will raise the lift without you wanting to. It's very contained in this case here. And then, okay, so we'll look at lifting now because we've acquired a game element. So now we want to raise our lift properly to the proper position. So that's what we had previously. Press the Y button. Here we can see that we don't even need to have a gamepad input in order to raise our lift because we know that we have a game element. We can safely assume that we can just raise our lift because the previous state was satisfied. So that's one of the main benefits. When previous states are satisfied, you can correctly assume that everything has gone well, and you can raise the lift without having to confirm with the driver you want the lift raised. So we set it to our score position, and then in our lift code, we can have a method that returns true when it reaches the proper position. You can use encoder data for that. So yeah, you can check the position of the lift, and if it's reached its proper position, then you can use that method to return and say, okay, we're at the proper position. Now we are physically able to score. So yeah, let's look at scoring. Before we had it that we press the X button and then we can score our game element. We can do something very similar with switch cases. We can have our X button because here driver input is pretty important because you need to navigate towards the zone that you have to score in. So here we can confirm with the driver, okay, when we press X, we will score our game element. So yeah, then, I mean, the lift will be raised otherwise, so you can still drive around and navigate to where you want to be until you press the X button, and then we will score our game element. So yeah, so from that, we can say, all right, we finished our entire cycle, which was intaking, raising our lift, and scoring. So now we can begin the process of resetting everything back to the start, to where we began, and then do another cycle again after that. So what that'll look like is we had before pressing the A button to lower down the lift back to its intake position. Here we can fully automate that. We can see if the lift has scored, so whatever scoring mechanism you have, if that has completed its action, then we can automatically lower the lift to its intake position and then loop back around to where we started, which was intaking. So again, this requires no input. This is all based on the robot and its states it's in and what actions it's completed and what is left for it to complete. So yeah, when we go back to intaking, then we'll go back to where we started. I mean, using our switch case here, we can see we only had one driver input required, which is just pressing the X button to score. So instead of the 4 that we had before, we're able to condense it down to just one button and automate a lot of the menial tasks during a teleop period that the driver shouldn't really be focusing on. The driver should be focusing on really navigating and driving. So instead of like trying to time mechanisms, so this is what good code can do for a robot. It can make it a lot easier on the driver and allow the driver to only press one button to score a game element, to do a cycle. And it's a great benefit for a lot of cases, a lot of situations. You can write a finite state machine for other aspects of your robot as well. You can probably think of like where that might be helpful for you. But you guys might have a question like, okay, what if something goes wrong along the way? Like, what if I want to, what if I want to reset in the middle of my state? Like, what if I'm trying to lift, but the game element fell out of our lift and I need to reset everything and get back to the start so I can try again. Like, stuff like that happens all the time. Mechanical issues or driver issues. So you can add this if statement before your switch case in your main loop that will automatically set the state to a resetting state whenever the B button is pressed. So you have to make sure that the B button is available and not used by other inputs in the mechanism, but this allows you to break out of any state that you might be in to reset and try again if something goes wrong. That's pretty important because it happens all the time, like I said.
and it makes it robust. Like you'll never be stuck in a state that you don't want to be in, and you'll have to like continue doing the actions even though you're missing like key elements of your game element, or you're missing like your slide didn't go up, or something like that. This allows you to start it over again and try again properly this time. Yeah. So here's like a overviewing diagram of what I just discussed. It doesn't really start at a single position, but I chose intaking to be like our starting point. And then, right, you acquire a game element, so you go into lifting, and then once it reaches its position, go into scoring, and then here we confirm with the driver that we actually want to score with the X button, and then we go back to resetting, bring everything back down, and ready to intake once again. And you can see at any given point, if you press the B button, you'll immediately go back to resetting, and then you'll be able to intake any other game element that you want. Any questions so far? Yes?
For the scoring, based on what you showed, it wasn't defining which of the poles. I know this is for the FTC game, so there's different heights for dropping code.
Right. Okay.
This is just a generic,
This is like pseudocode, like an example, but you can definitely choose different poles if you wanted. In this scoring state, you can say you can define the Y, A, and X button, for example, as like your 3 different levels for the poles, and that's where you can add that functionality here. So if you wanted to select a specific height for your lift, you can do that here. But yeah, this is just some like basic pseudocode, but it's easily expandable if you wanted to. Yes. Sorry, can you speak up a little bit?
Do you have these slides and examples available online anywhere?
Yeah, so after this lecture is finished, these slides will be available, and then we'll also we have our GitHub repositories with examples as well. We'll provide links at the end. Any other questions? Yes?
Kind of related, but
Okay.
what kind of sensors do you recommend for like detecting that your intake packaging is headed?
There's a lot of different options. We use color sensors typically because in FTC and FRC as well, game elements are red or blue, and color sensors work really well with that. The only thing I suggest is have your color sensor really close to where your game element is going to be, because otherwise it might it reads wrong, or it might be there's a really like short distance in which it's really good. That's what we typically use, color sensors, like mounted really close to where our element is. We expect our element to be. Yeah, good question. Any other questions? Yeah, sure.
It kind of looks like you're not using command-based programming, which is part of WPI lib, right? How do you like compare writing your own like state machine versus trying to use command-based programming?
I'm not too familiar with WPI lib, so not sure how to answer that question.
I mean, it seems like well, at the end of the day, Finite State Machine is it's really meant like for an organizational purpose, like above all else, like being able to code like a logical flow, right? And then later, like whatever else you need to run just fits in here, right? I think Paul said earlier that you could easily scale this scoring case to have different like lift positions, right? So you could do the same thing for running like other commands or functions within different states. You just have to put them in the right place.
Yeah. Anyone else? No? Okay. All right.
Then I guess just like as a quick overview, like pros and cons. Like Finite State Machines they're not super complicated, right? Provided that you know like the flow of how your mechanisms are going to work, you could reasonably like while making the presentation, me and Paul on paper we made like the state diagrams that we can like double check our pseudocode. So provided that you know like the flow of the game and the flow of your mechanisms, they're relatively easy to implement, and they're completely separate from like your other mechanism code, right? So if you implement like interrupts or delays, they won't unless you choose to. They won't affect, say, like your actual drivetrain, right? Like as you're moving, or any other mechanisms that you have. For example, like if you had a turret for like power play, right? So, but the real big con is that it's situation specific. There are times where you're not gonna want to use a finite state machine because there really isn't any point. So for example, if you're writing like an autonomous, you wouldn't want a finite state machine for telling your robot to go to different places because, for example, I guess to use this year's game as an example, if you're going to go and score a cone and then park, these two states of being happen one after the other, right? So there's no point in making a finite, like a switch case for that, as opposed to just like, okay, I go to the pole, I drop off my cone, and then I leave, right? Just like literally like a linear sequence of like functions. Yeah. That's.
Is there one slide or no?
I think last slide was just like questions. Yeah. These slides will be available later through like StuyPulse, but like our GitHubs are here as well as like Paul's power play slides from this year, like as lift mechanism, and then a freight frenzy scoring mechanism from last year. In case you guys want to look at them for examples, they're pretty clean. It's just like the pseudocode that we had, but implemented for like those games with like interrupts, delays, and all manner of clean stuff.
You can see an example of for linear slides for using for the 3 different heights for the poles. That's in there as well. And yeah, do you want to talk about like runnables and threads? Because we have time. Dude? Any questions? I mean, we can. We have time.
All right. So I think just like as a quick aside, I know in the beginning we talked about, or I keep mentioning like delays, right? Because whenever you're running, like for example, I guess to take this year's game example, when you're raising your lift, you don't want your claw to open up prematurely, right? So you need to be able to implement a delay on the claw, and there are 2 ways of doing this. One is with just like a timer. What you can do is, that right here when you're lifting, say that you had a timer before, you could reset your timer right here, so that over here when you're scoring, you can just check, have like, I don't know, like 2 seconds passed, and then I can actually start scoring, right, and then start resetting. And the other way is to
you can, so like if you had like an if statement at the top here, like if my timer seconds elapsed from the last state is 2 seconds, then we're able to score. That's one way. Java has an elapsed timer class if you want to look at that. Another way is using threads and runnables. Here's an example from our code this year. Here. So this is for the low junction, for scoring on the low junction, but it works for any. We have a runnable, which in Java creates a separate thread to run actions in. So for example, if you have your loop of, like your loop down here, for example, running your lift code, you don't want to have like a wait seconds or a sleep inside of that, because it'll pause all your other code in there. So your slides are not getting any update information. You won't get any encoder information. And yeah, so you definitely don't want to do that. So if you want to do thread.sleep, or if you want to sleep inside of to time your mechanisms, you need to make a new thread and then run that thread. So this is the syntax, basic syntax. It's a runnable in Java. This is its default, I think. And then we have our slides, which extend to the low position. And then we can sleep a certain delay that we specify, number of milliseconds, and then we can then switch the state after that sleep is done. So because slide state is like global to the entire class, we can access slide state here, and then we can switch our state once our delay is finished. And then in our initializer method, you need to attach that runnable to a new thread, and then name that thread. We call it low thread here. And then inside of your main loop code, you can low thread.start, which will start that thread, and then it'll run it once you want it to. So like if we press our gamepad A, we'll run our low thread, which will have a sleep in it, and the state won't switch until that low thread finishes and the thread exits, and it'll return the new state, and then it'll switch to our waiting for retract, which is waiting for more input to retract the slides. All these threads are surrounded in try catches because whenever you do a sleep inside of a thread, there's a potential it becomes interrupted, so you need to catch that exception, as well as Java doesn't want you to run the same thread multiple times. So like because this is a loop and the switch case will be evaluated every time the loop runs, it'll try starting this thread multiple times if you press A like accidentally twice. You need to catch that as well. So that's this exception here. Yeah, I don't think we discussed why there's a break here at the end of every switch case. I'll explain that now. So if our current state is rest, this switch slide state will evaluate to rest. So it'll run this block of code, and then we want it to break, because if you don't include a break here, it'll just continue evaluating the rest of the cases. That's just by design. It allows you to, let's say, if you want some code to happen in 2 states, then you won't include this break. But we want this state to be contained and not run the rest of the code. So you need this break here. That's important. You realize that if you don't have it, you'll have like multiple switch cases true at once, and it gets confusing. So yeah, you have to include that at the end. And yeah, that's pretty much it. Using threads, I think, and runnables is really cool because these are really simple right now. We're just extending, sleeping, and then switching our state. But you can have like many different actions and sleeps in here, all time-based. If you have a really complicated mechanism that you want to run and you timed it perfectly, then you can all include it in a single thread that you can call any single time, like a sequence of commands, basically. Yeah.
I know we just went through like somewhat new topics on the fly. So do you guys have any questions?
Yeah, feel free.
Yeah.
We can give more examples if you need. We have a bunch. Or like it could be unrelated also.
We're
open
like
to
on presentation in general. Yeah.
Yeah.
Has state control been used like this in FRC? Are there any examples of that?
I think so.
I mean, well, we don't know because we're not on FRC, but it wouldn't surprise me because like we said before, robots are event driven, right? Like you're gonna have like flows like this, regardless of like whether you're doing FRC or FTC, right? So this is just like programming paradigm is useful or would still probably have a lot of use in FRC.
Yeah.
Just to combat this question, just the other day I was coding for a storage drive. And one of the things was if the angle you want to go to is too far from the one you have, you would swap states and like reverse the coordinates you're using.
Oh,
That's kind of I didn't even know what the time is sort of a multi-state system.
Yeah. So he mentioned like he was coding a swerve drive for FRC, and if the angle of the swerve module was too far, then he would switch a state, which will correct that. And he said, yeah, that's an example of how this can be used. So it's not specific to FTC. You can use it in any part of code, really. And robot code is like really easily visual. Like you really visualize using something like this in robot code. Yeah. Any other questions?
All right, I guess just like a closing remark is that sometimes we kind of forget that robotics is a career, right, beyond like the first bubble. This is like finite state machines are like actually like it's developed beyond like it wasn't developed for first robotics, right? Like if any of you guys go on to do robotics related careers in the future, this is a really powerful tool for like automating and just like dealing with like stuff you're gonna have to build in the future, right? When you don't have like a linear flow to how stuff works. It's just a really useful way of thinking about stuff like mechanisms you're going to build in the future, like in first or out of first.
Yeah. That's pretty much it. We don't really have any more to add unless you guys have questions or if you want to come up and ask us questions and show examples. We can definitely show examples. But yeah, that's all. It's just a short presentation. I think there is not. I mean, you could definitely make this more complicated than what we showed. This is just like a simple example. But yeah. All right.
Yeah. I mean, pretty much done.
Yeah, that's pretty much it. If you guys want, you can come up, right, ask questions, and there's other presentations going on as well right now.
Stick around for the whole day. We got like a bunch of stuff going on, guys.
Yeah, it's just.
Don't leave so soon.
Yeah. All right. Thank you.
Me when I go
That's fine.
No, I think it's because I got that. If I can take a picture really quick.
Yeah, sure.
Thank you so much for your presentation, guys. I really appreciate everything.
Thank you.
Have a good one.
Thanks.
Yeah, that was crazy, guys.
No, Paul's crazy, bro. The peace serve presentation.
Yeah. How was the chat? Was it
So I use these kind of like things in it, but I don't know what they're called. So like,
There you go.
This is like beyond, like a beyond robotics. Yeah, like there's a whole ass like huge Wikipedia article on how David was versus robotics. It's like you know,
you said that the slide was available.
Yeah.
Where
wait, Austin.
Yeah. Where the?
Are you guys gonna release like a? Wait, is it onto like the schedule
Is it on
slides?
Instagram?
Slides.
These slides.
Oh, it is not.
Are you gonna release it release it later?
Where is it
on
gonna
the
be
Insta?
released?
We will release it. Where will we
On
release
your
it?
link tree? Hold on. Let me give us a second.
We will release it.
No, it's on schedule.
Is it not on this?
This is important, guys. People want to see the slides.
I was wondering how you guys like started
Your Instagram, right? Just do it on your Instagram.
You mean like
Do you know if Izzy's here?
so
Look out for. Do you follow StuyPulse on Instagram? Follow StuyPulse on Instagram. We'll make a post there. StuyPulse.
If you don't care about robotics, then you have to find. So, for example, like I learned coding because like I was watching a video of Gravity.
We're gonna make a post about it, and it'll be in our
So
link tree.
it was like
But
it
if
was
you
like
want
this,
me
like Disney,
right now, I can send you a copy of the slides.
the
Just
example like
you
little
have
secrets,
them.
like episode that
Just
was
give me
through email.
yeah. I can email you a copy.
I started like learning programming to make my own like version of that stuff. So like find something you're interested in. It's like spend like a nuts amount of time on it, and then as long as you're coding while you're doing it, you'll get better at it, and you'll also get like a deeper interest. It'll start to become like part of your life.
What's your email? Okay.
NYC students.
There's also really cool stuff like
Is this
ray
correct?
tracers, like
Yeah.
just like if you because coding is a tool, like programming is a tool to do like a bunch of different stuff. Yeah. So if you find something that like piques your interest, you can find a way to like program something for that. That's kind of like the way to think about it.
All right. Check your email.
It's for a bit, but it's a good bit.
Are you? Is everything going to be like within this presentation? Yeah, I believe it'll work.
Great.
And is it okay if I use this webcam?
Yes.
Is that magnetic?
Yeah, alright. I'll wait until 15. Melody. Riddle me this. You know all of the stuff in this lecture because you were a 2022 rookie, so it's about you.
Oh, okay. I'm so excited to learn about me.
Are you gonna take notes? Do you want me to just put this in Maiden's Drive? I can just put this in Maiden's Drive. Guys! Guys! Go to How to Have a Successful FRC Season. You know this. But you know this because it's about how I ran the maiden. Oh my god. Guys! Oh my goodness, there's cyborgs! Guys! Warren, do you have a Red Bull on you? Can I have it? Thanks! What flavor is it? Can I have it? Can I pay you back? Okay. I do owe you one. I don't know when I'll see you, but I'll owe you one. Oh, I'm so sorry. I don't know why people from the Bronx science teams are here. You guys don't need to know this. All right. Hi guys, it's 11:50, so I think that means I go now. Give me a sec. I got words here. So ignore the maiden slides theme. This is not a lecture on how to move on. Okay, this is why people don't join your team. Or it was going to be called Why People Don't Join Your Team, and then I was like, that sounds so mean. So that's why it's not called exactly that. But I mean, I kept having this experience when I was like technician last year, where I'd be sitting in the robot cart next to my alliance's technicians, and they would hear the maidens cheer, and they would look over at them, and they'd be like, oh my god, how many people are on your team? And I was like, what? Like, it's like 40 people, but we had like a couple hundred trying out, and they would look at me like I was speaking another language. They would look at me like I was insane. And I think that, like, it's not that crazy. I think that it's all about, like, how you broadcast your team to your school community, right? And the reason I say school community is because it's New York City, the vast majority of teams are going to be school-based. I don't know why there are people from the Bronx science teams here. You guys know this because this is about how I recruited you. Whatever. Who am I? Oh, how'd that get in there? That is a vintage Pev picture. I'm Pev. My pronouns are he, him. I was on 2265 The Iron Maidens from the Bronx High School of Science. These days I go to Yale. I am involved with First at Yale, the Yale Student First Volunteering Group, which is really cool, and you guys should all be in it too. It's cool. So, why should you listen to me? How do I maybe know what I am talking about? When I was a senior on 2265, I was head of engineering, and I procrastinated all my homework by working on our tryouts and recruiting coordination. If you know anything about Bronx Science Robotics, you know there are two teams. We did all of our recruiting coordination together, so this was with 1155. And the year that I was a senior on the team, we had about twice as many students trying out as we usually did. My Bitly analytics, because I made like Bitly links for all our tryouts information, had like 1,600 total clicks out of a 3,000 student body. Between both teams, we had like 200 people trying out for like 40 seats, 30 seats, which like I don't want exclusivity to be a measure of like good, but when you have to have tryouts, having the biggest tryouts pool is good. And then I tried to talk to my rookies, as well as people who eventually decided not to try out, about why they did or didn't try out, like what was the deciding factor for them. Before we start, I do have a story to tell. Picture this. It is 2013. It is Ultimate Ascent. That is loud. You may recognize this as Brunswick Eruption. Noah Tomlong is a sophomore on FRC 694. He's just joined the team, and he is driving at Brunswick Eruption. He is not very good at it. If you watch the opening minutes of the match, it looks completely normal. The robot Desiree is moving. Good for him, right? Now, if you slowly, no! That was the wrong button. If you watch the last, 30 seconds of the match, you may notice something interesting happen. And this is just because Noah asked me, is this going to be in your lecture? And I was like, now it is, right? Okay. Endgame is soon. We're getting there. This serves no purpose. This is just to make fun of him. Okay. Wait for the endgame buzzer. This is the important part. Okay, you will notice that 694 StuySplash is wearing the red bumpers. And this is the blue pyramid and the red pyramid, which are the hangers in Ultimate Ascent. The StuySplash robot goes to climb the blue pyramid, and Joe Clay, who is trying punching Noah down with them, and he's like, this is what will be known as the wrong pyramid. And we'll get Noah way for it 9 years later, which is now. Now is 9 years later. That's all. That's just, I wanted to bring that up. I wanted to bring that up because he asked me if it was going to be in the lecture, and now it is. Okay, now we're moving on. I have real things to say now. Just a second. Let me let me represent this. There we go. Okay, interest and awareness. Before anybody goes to a meeting, before anyone ever considers joining your team, they should have heard of it, right? Recruiting is a larger process than the 2 months of preseason when you're actually taking new members. All year, you and your team should be active in your school community promoting robotics, so that in preseason, when like you send out the email or you put out the flyer that say, hey, robotics is accepting new members, there should be people who've been hearing about you all year and go, yeah, I want to do that, right? There should be people who are already aware of what you do. And theoretically, that should be everyone. You want to be so annoying, you want to be so loud, you want to be so hard to ignore. More cool numbers about why you should listen to me. This year, and again, this is why like Bronx Science teams don't need to be here, because this is stuff you know. This year we saw even more people trying out for the Bronx Science teams than we did last year. And preseason was structured almost the same, like the preseason recruiting period was almost the same. So like what could have been different? In 2021, we were at home. It was COVID. We couldn't spend our whole year being really obnoxious and loud and really hard to ignore. In 2022, we could, and we could make our school community very aware of us. And so that's why I say, like, what you do during the rest of the year to be obvious really makes the difference. I will also note that, like, this is not going to be specifically tailored towards teams that have tryouts. I will mention at the end what I think tryouts accomplish, and I will acknowledge, like, generally, we wish we didn't have them. But they do serve one thing, and we'll get there. Okay, so actively recruiting in preseason. This is the list of things that you do in the like 2 months when you're taking new members. This is the really big stuff. Yes, wait, is this the order the slides are? Sure it is. Okay, so the first thing you do, I'm not having the slides, we're fine. The first thing you do is like flyers, super easy to distribute. Like you make a joint one, you put it everywhere, you put a QR code on it, you put a bit.ly link on it. Everything you send out has QR codes, has bit.ly links. Your ultimate goal in this preseason period is to make it like absurdly easy to gain information about your team. Because if people have to put in effort to be interested, more and more people stop caring before they end up joining. And so you want to make it super duper easy. That's why like you can also take school-wide routes, like at Bronx Science. You can go through the admin to send like an email to the entire student body, or like you can put it in the morning announcements. Like things like that. It's generally, at least at Bronx Science for the morning announcements, like that's a captive audience. People have to sit there and listen to you go, hey guys, robotics is having tryouts this week. And they're like, oh, okay. It's a little thing, but like you just remind people that you're there. Homeroom visits. So what I mean by this, and this was a lot of effort on my part, but I think it is so worth it. We sent one Cyborg and one Iron Maiden to every single freshman and sophomore homeroom in fall of 2022, and they just showed up and they said, here's what we do on robotics, and they wrote our little bit.ly link on the whiteboard, and then they left. And I think it's a great opportunity. It's a small space where if people have questions, they can ask it, and it's not like 100 people at your interest meeting. Or if, someone hasn't been reached otherwise, like this is definitely going to reach them because like with Bronx Science, you have to go to homeroom generally. I mean, every Cyborg and Maiden that was going was skipping homeroom, but I got them out of it. It was like, this was a large coordination effort on my part. I had to go look up like the room numbers, but I think it worked really well. And when I talked to people, they said that worked well for them. Info sessions, big interest meeting. You say, if you are interested in trying out for robotics and joining robotics at all, you have to come to this. We will be in the auditorium. We will be telling you about what robotics does, about how to try out. You can ask questions, come. Again, this is just a really good way to like broadcast information to people that are interested. Having an open email line is cool. This says here, don't make it a team member's email. This was my fault. For Maiden's engineering tryouts, I said, you can just email me if you have any questions. And I got questions like, what is a cube? And that didn't go so well. So like, you should have a team email. You should have like, there's FE Maidens at bxscience.edu or something of that nature. Like that sort of thing is where you should put their sort of emails. Because definitely like having a place where a student who's interested in your team can just email you and ask questions, like in a place that is completely like no judgment, there's not like another room of people like staring at them while they ask it, is a really productive thing. It was a great way to have people learn about your team. Again, don't make it somebody's email. I was like, there were days where all I did was answer tryout emails, and that is not a productive use of your time as well, theoretically, it's like leadership that's doing this. Social media. Okay, this is something that the Iron Maidens and the Cyborgs would put out like a joint Instagram post. It'd be like, here's when the interest meeting is. And I genuinely think that every single Iron Maiden and every single Cyborg that had Instagram, like, reposted it on their Instagram story. People who I never otherwise see active on Instagram repost it on their Instagram story because it's like, it's a way to get it out to your school community. Like, people on your team are going to be able to reach, like, groups of people within your school that you, just by, like, broadcasting it to the greater everyone, are not going to be able to reach so directly. So that's, like, a really good method of doing that. And I think it comes really close to the way that a lot of teams recruit normally, which is, like, word of mouth, which is effective, but, like, not on its own. Starting first. Starting first is a very particular thing. Fear. Okay, you know what? We're just gonna push through. I don't know where the charger for this bad boy is, so I'm just gonna push through. So starting first is a very particular thing. I had people, like underclassmen that I knew that I worked with for other stuff, tell me like, oh, I really want to try out for robotics, but debate starts first, and debate doesn't have tryouts, and if I go to so many robotics meetings, like if I go to enough robotics meetings to try out, I'll miss so much debate that I'll be removed from debate, and then I'm not even guaranteed to be in robotics. And so like I can't really try out for robotics because I'm already involved in debate. And so that's why I say start first. It's very effective at gathering more people, even if this means that you're in a school where like the high school is grades 7 to 12 rather than 9 to 12, like if it's a K to 12 school, and you can't recruit for FRC because FRC is technically only for 9th graders, but then by the time you get to recruit for 9th graders, like everybody's already involved with other stuff that they care about, you can start them in 7th grade because you need to be able to get people like committed and involved as early as you can so that people who might otherwise be interested are not already occupied with other stuff by the time they are capable of joining robotics. My laptop turned off, that's fine. Wait, there we go. I lost this slide and then I found it. So all year round, you should still be reminding your school community that you exist. Like that list of things that you do in preseason is cool and fun and fine and nice. But you really want to be hard to ignore because, let me turn on my laptop very briefly. Because I did write things down, I promise. Okay. Beep bop 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 bow. So some of these are like a little more passive, like the team as an organization has to do them once and then they take care of themselves. And some of them are like something the team as an organization has to do like regularly and upkeep and maintain, but they're all like worth it and good and generally otherwise good. So the first thing, beep 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 beep. You do all your normal stuff, but you do it just very conspicuously. I think if you've been in the Bronx Science like robotics hallway during build, you know that we're very hard to ignore. Like you see people in merch, huddled around laptops, arguing about matches, reviewing CADs, reviewing code. You definitely know that the teams are there, which I think is like, it was something that teams that didn't have a lot of members would express to me, like, I don't even think people at my school know my team exists. And I was like, how? Just be like loud and annoying. It's very easy. And so even if you're moving through the hallways at Bronx Science, like you just see people and you can tell that they're on robotics, usually because they're wearing merch. And that's another thing, like you all have team merch. If you encourage people to wear team merch to school, it's just another way that like you become very hard to ignore. If you're walking past someone in the hallway and they're wearing, I don't know, a bright purple sweatshirt, a fire truck red sweatshirt, like it's very easy to look at and be like, oh right, robotics. Which is sort of the theme of all this stuff. Like, it's not even about convincing people that robotics is like the best thing and the thing that they should join. It's just about convincing people, not even convincing, it's about reminding people that you are there. Because if people learn that you exist, like a week before tryouts, or a week before, like, build, they're a lot less likely to join than if they've been hearing about you all year and they're like, yeah, we're ready to do this, right? And so then, strategically placed trophy case, TBD. Like TBD on the core values front. As much as all of us, as like good first students and ascribers to the core values, know that it is not about winning, strictly speaking, a blue banner is a very flashy thing. Like some students' first experience with your team can be like a big blue rectangle that has big letters that say winner on it. And like that can be what makes them join, and you can indoctrinate them later. Like it's fine, you know? And so like the strategically placed trophy case